Good day everyone and welcome to Valenzuela Live for Mathematics in Grade 6. Once again, I'm teacher Marlene Perduce from Constantino Elementary School, your Facebook live streaming teacher for today. And we are now in the first week of the fourth quarter. But before we begin, may I remind everyone to please prepare their math module, pen, and paper. And to actively participate in our discussion, you can write down your answer in the comment section. So based on the Department of Education Most Essential Learning Competency, at the end of the session, you should be able to determine the relationship of the volume between a rectangular prism and a pyramid, a cylinder and a cone, and lastly, a cylinder and a sphere. So in this lesson, we're going to learn more about volume. Specifically, we're going to learn what volume is and what kind of units we use to measure the volume, and how to compute the volume of each solid figure and their relationships to other solid figures. So to understand what it means, it will help us if we go back just a little from the previous topic or previous lesson. So let's have a quick review. So let's solve for the area of the following plane figure. So I have here a plane figure or a square with a side of 3 meters. So what do you think will be the area for this figure? You can write down your answer in the comment section. Okay, very good. So the area for this square is 9 square meters. So to solve for this, all we have to do is to apply or to use the formula in finding the area of a square, which is s squared or side times side. And then substitute the value of the side, so that is 3 meters times 3 meters, and it will give us the area of 9 square meters. Another figure, let's compute for the area of a triangle with a height of 4 decimeters and a base of 5 decimeters. Again, write your answer in the comment section. Okay, very good. The area for this triangle is 10 square decimeters. So the formula in finding the area of a square is we just have to multiply the base and the height and divide it by 2. So 5 decimeters times 4 decimeters equals to 20 square decimeters divided by 2. And now the final answer is 10 square decimeters. And that is now the area for the triangle. And for the last figure, let's solve for the area of a rectangle with a width of 2 centimeters and a length of 5 centimeters. What do you think will be the area for this? Okay, very good. Again, the area for this rectangle is 10 square centimeters. So all we have to do is to multiply the length and the width. So 5 centimeters multiplied by 2 centimeters, and it will give us the area of 10 square centimeters. Very good, grade 6. So on the previous lesson, we have learned about the area and surface area. Recall that the area of a plane figure, so we solve for the amount of space taken by a two-dimensional figure. But when we talk about solid figures, aside from solving the surface area, we also solve for the amount of space occupied by it. And that's what we call the volume. So volume is defined as the amount of space occupied by the solid figure. So let's go back again to the area. So when we solve for the area of a particular figure, we count the number of square units taken like in this figure. So remember that the square units is obtained by multiplying the two dimensions of a plane figure, like in this example. So the length of the rectangle is 4, 1, 2, 3, 4, and the width of the rectangle, or while the width of this rectangle is 2 units. Then by multiplying the length and the width, or the 4 units and the 2 units, we obtain a product of square units. So the first thing you need to know is that volume is a quantity that all three-dimensional or solid figures have. So the volume of a solid figure is the amount of space occupied by the figure. So it is measured in cubic units. So let's start with the prism, or with this prism. So how are we gonna calculate for the volume of this prism? So this prism has a length of 4 centimeters or 4 units, a width of 2 units, and a height of 3 units. So what is the volume of this prism? So you can get the volume of a solid figure by counting the number of unit cube that can fit in the figure. So unit cube is a 1 by 1 by 1, meaning its length, width, and height measure 1 unit cube, or 1 unit each. So this cube is a 1 cubic centimeter, or 1 cubic centimeter cube. So now, how many cubic units or cubic unit can fit in this figure? So here's the example. As you can see, each layer of the figure has 8 unit cubes. Since there are 3 layers on each layer, or since there are 3 layers, and on each layer there are 8 unit cubes, then there can be 24 unit cubes that can fit in this figure. Then this 24 unit cube is the volume of this prism. So let's have again the same prism with the 4 units length and 2 units width and 3 units height. So notice that by multiplying the 3 dimensions of the solid figure, namely the length, width, and the height, we obtained 24 units, which is the volume of this prism. So another way to solve the volume of a solid figure is simply by multiplying the area of the base by the height. So recall that the base area is obtained by multiplying the length and the width. So therefore, we can say that the general formula for the volume of a solid figure is base area times the height. So the general formula can also be applied in solving other solid figures like cube, triangular prisms, and cylinder. So like in this example, a cube with a side of 5 centimeters. So what do you think will be the volume for this solid figure? So let's see. So let's apply the general formula, which is base area times the height in solving for the volume of this cube or this solid figure. Since the base of this cube is a square, and in finding the area of a square, we use the formula s squared and multiply it by the height. And as you can see, we all know that the cube has a characteristic that all edges or all sides have the same length. Okay? So we can now say that the height in this formula can also be named as the side of this cube. So therefore, we can say that the volume of a cube can be computed by multiplying all the sides, multiplying the three sides of a cube. Or we can say volume is equal to S cube. Or in some references, we can see this volume is also equal to E cube or edges to the third power. Okay, so let's substitute the given measurement in our formula, which is 5 centimeter. So volume is equal to 5 to the third power. So 5 times 5 times 5, and it will give us a product of 125 cubic centimeter. And this is now the volume of the given figure or the cube. Take note, class, that the formula in solving for the volume of a cube is volume is equal to S cube or volume is equal to E cube. So let's apply again the general formula in solving for the volume of a triangular prism. So as you can see, the base in a triangular prism is a triangle. So going back to your previous lesson, so to compute for the area of a triangle, we use the formula base times height divided by 2. So therefore, we can say that the volume is equal to base times height times the height of the solid figure. So the height here in the base area is pertaining to the height in the base of the solid figure. So let's substitute again all the given length. So 4 times 5 divided by 2. So that is 20 divided by 2, and it will give us 10 multiplied by 12. And the volume now is equal to 120 cubic centimeter. So take note again, class, that in solving for the volume of a triangular prism, all we have to do is to solve first for the base area of the figure, then multiply it by the height. Another application of the general formula is in the solid figure, what we call cylinder. So we all know that cylinder has 2 circular bases. So to compute for the area of a circle, we use the formula pi r squared. So multiply it by the height, so it will give us the formula in finding the volume of a solid figure. Then again, let's substitute all the given length. So pi is equal to 3.14 multiplied by the 3 meters as our radius in the figure. Then multiply it by 9 as our height in the cylinder. Then express first the exponent. So 3 squared will be equal to 9. Then multiply all the numbers, and it will give us a product of 254 and 34 hundredths cubic meters. So this is now the volume of the given figure. So again, take note, class, in solving for a solid figure like this cylinder, we use the formula pi r squared times the height. So that is from the general formula, base area times the height. Now let us discuss the relationship of the volume of a pyramid to the volume of a prism with the same base and height by watching this video clip. Okay, so what have you observed, class, in the video? Yes, the pyramid and the cube in the video have the same base and height. And based on the video, it takes 3 pyramid containers that are filled with water to fill the cube container. So this relationship means that if the pyramid and the cube has the same base and height, we can say that the volume of a cube is 3 times the volume of a pyramid. Or vice versa, we can say that the volume of the pyramid is 1/3 the volume of the cube. So this result leads to the formula in solving for the volume of a pyramid. So to solve for the volume of the pyramid, that is 1/3 the product of the area of the base and the height. Okay, so let's apply the learnings that we get from the video in solving for the volume of a pyramid. So again, to solve for the volume of a pyramid, so just multiply the base area times height by 1/3, or we can divide the base area, the product of the base area and the height by 3. So using the given in the figure, so let's substitute all the given measurement in the given formula. So that is 10 times 8 times 6, or 10 and 8, or just by multiplying 10 and 8, it will give us the base or the area of the base. And then multiply it by the height, which is 6. And then after that, divide it by 3. So we will give, it will give us the volume of the pyramid. So 10 times 8 times 6, that is 480, divided by 3, that is now 160 cubic centimeters. That is now the volume of the given pyramid. So again, take note, class, that in solving for the area, volume of a pyramid, we have to multiply the base area or the product of the base area and the height by 1/3, or we can divide the product of the base area and the height by 3. Okay. Another relationship is, this time let's discuss the relationship of the volume of a cone to the volume of a cylinder. Again, with the same base and height, by watching again this video clip. Okay, so what have you observed again? Grade 6. Correct. The cone and the cylinder in the video have the same circular base and height. So based on the video, it takes 3 cone-shaped containers that are filled with water to fill the cylindrical-shaped container. So this relationship means that if the cone and a cylinder has the same circular base and height, then we can say that the volume of a cylinder is 3 times the volume of the cone. Or vice versa, the volume of the cone is 1/3 the volume of the cylinder. So this result again, or the result leads to the formula in solving for the volume of a cone. And that is 1/3 of the area of, 1/3 the volume of the cylinder, or 1/3 the area of the base times the height of a cylinder. So take note again, class, that the base area of a cylinder, cylinder has a circular base. So meaning to say, to solve for the base area, we will use the formula pi r squared and then multiply it by the height. And again, multiply it by 1/3 to get the volume of the cone. Okay, so let's apply the given formula here that we get to our figure, or to our solid figure. So using the formula in finding the volume of a cone, which is 1/3 times pi times r squared times height, or we can write it as pi times r squared times height divided by 3. Then by substituting the given length, so pi is equal to 3.14, then the radius from the given is 3 decimeters, and then the height is 7 decimeter. So first, let's express the exponent. So 3 squared will be equal to 9. Then multiply it by 3.14 and 7. So multiply all the numbers in the top. It will give us 197 and 82 hundredths. Then divided by 3. So the volume now in the given figure is 65 and 94 cubic decimeters. So take note again, class, that in solving for the volume of a cone, we have to consider this formula. Okay, for the last relationship, let's discuss this time the relationship of the volume of a sphere to the volume of a cylinder with the same height by watching again this video clip. Okay, so what have you observed? That's right. The sphere and the cylinder in the video clip have the same height. So based again on the video, the cylinder was only 2/3 filled with water when it was filled with a sphere-shaped container. So this relationship means that if the sphere and a cylinder has the same height, the volume of the sphere is only 2/3 of the volume of the cylinder. So this result leads to formula in solving for the volume of a sphere. So that is 2/3 multiplied by the volume of a cylinder. Or 2/3 times pi times r squared times the height. But take a look, class. So in sphere, when we say radius, that is the distance from the center to any point in the circle. So this is the sphere. This is the radius. We can also say that the distance from the center of the sphere to any point in the sphere is also a radius, right? And this one also. So we can now say that the height in the sphere is equal to 2 radii. So from this formula, let's replace the height by the 2 radii or 2r. And then express the given equation. So 2 multiplied by 2/3, and then r squared will become r cubed. So the formula now will become 4/3 times pi times r cubed. So this is now the formula in finding the volume of a sphere. Okay, so let's apply again the obtained formula in our given solid figure, which it has a radius of 2 centimeters. So we can also rewrite the given formula, which is 4/3 times pi times r cubed, by like this. So 4 times pi times r cubed divided by 3. So let's substitute all the given length. So 4 times 3.14 times 2 to the 3rd power. So let's express first 2 or the exponent. So 2/3 will become 8. Then multiply it by 3.14 and 4. So 4 times 3.14 times 8. Then the product is 148 hundredths. Divided by 3. So the final answer now is 33 and 49 hundredths cubic meters. So this is now the volume of the given solid figure. Okay. So these are the summaries of the formulas that we have discussed earlier. So take a look at this and be reminded with this formula. Okay. Since you already know the different formulas that we have discussed earlier, so I think you can apply those formulas in finding the volume of different solid figures. So this time, let's apply those formulas in our activity. And this activity is entitled the Math Quiz Show. So here's the mechanics of our activity. So all you have to do is to read the problems carefully, solve, and choose the letter of the correct answer. So write your answer, of course, in the comment section. So you will be given 15 seconds to answer each question. Okay, so let's start with question number 1. So which has a greater volume? A box that is 6 centimeters by 5 centimeters by 4 centimeters, or a box that is 5 centimeters by 5 centimeters by 5 centimeters? Is it letter A, a box that is 6 centimeters by 5 centimeters by 4 centimeters? Letter B, a box that is 5 centimeters by 5 centimeters by 5 centimeters? Letter C, both boxes have equal volume? Or letter D, none of the above? Your 15 seconds starts now. Okay, time's up. So the correct answer for question number 1 is letter B, a box that is 5 centimeters by 5 centimeters by 5 centimeters. So if we solve for the volume of the two boxes, So the first box, which has a dimensions of 6 by 5 by 4, the volume for that is 120 cubic centimeter, while the second box, using the dimensions 5 by 5 by 5, so just multiply all the length, the width, and the height, we will obtain 125 cubic centimeter as its volume. So therefore, the box that has a greater volume is the box that is 5 by 5 by 5. Okay, for question number 2, how many cubes with an edge of 2 centimeters can form a rectangular prism measure 6 centimeters by 4 centimeters by 4 centimeters? Is it letter A, 96 cubes, letter B, 48 cubes, letter C, 24 cubes, or letter D, 12 cubes? Your 15 seconds starts now. Okay, time's up. The correct answer for question number 2 is letter B, 12 cubes. So to solve for the number of cubes that can fit in a 6 centimeter by 4 centimeter by 4 centimeter rectangular prism, so we will divide the length, the width, and the height by an edge of 2 centimeter, or by the height, by the length, by the width, and the height of 2 by 2 by 2. So 6 divided by 2, then 5 divided by 2, and 4 divided by 2. So we will obtain 3 by 2 by 2. Then multiplying all the numbers, we will get 12 cubes. Okay, for question number 3, how many 8 cubic centimeters sugar cube can sand be put in a 4 centimeters by 8 centimeters by 8 centimeters box? Is it letter A, 32 sugar cubes, letter B, 33 sugar cubes, letter C, 34 sugar cubes, or letter D, 36 sugar cubes? Your 15 seconds starts now. Okay, time's up. For question number 3, the correct answer is letter A, 32 sugar cubes. So 8 centimeters is a sugar cube. So meaning to say, the dimension for this is a 2 by 2 by 2. So meaning to say, it is a cube with a length of 2 centimeter and a width of 2 centimeter and a height of 2 centimeter. So by dividing or by using this 2 by 2 by 2 in our prism, which is 4 by 8 by 8, so multiply all the dimensions, we will obtain 2 when we multiply 4 divided by 2, and then 4 by dividing 8 and 2, and 4 again by dividing 8 and 2. So by multiplying all the numbers, 2 times 4 times 4, we will get 32, which is the number of sugar cubes. Okay, for the fourth question, a liter is equal to 1,000 cubic centimeters. How many liters of water are needed to fill an aquarium that is 20 centimeters by 30 centimeters by 40 centimeters? Is it letter A, 1 liter, letter B, 24 liters, letter C, 1,000 liters, or letter D, 24,000 liters? Your 15 seconds starts now. Okay, so the correct answer for question number 4 is letter B, 24 liters. So if we compute for the volume of an aquarium using the dimension or using the length 20 centimeters by 30 centimeters by 40 centimeters, we will obtain a volume of 24,000 cubic centimeters. And since we all know that 1 liter is equal to 1,000 cubic centimeter, so therefore, 24 cubic centimeters is equal to 24 liters. Okay, for the last question, the volume of a block of ice is 9,000 cubic centimeters. If the base measures 30 centimeters by 20 centimeters, what is the height of the block of ice? Is it letter A, 300 centimeter, letter B, 45 centimeter, letter C, 15 centimeters, or letter D, 10 centimeters? Your 15 seconds starts now. Okay, time's up. For question number 5, the correct answer is letter C. So we all know that the general formula in finding a volume of a solid figure is by multiplying the base area and the height. And given the dimensions of the base, which are 30 centimeters and 20 centimeters, so compute for the area of the base, so multiply 30 times 20 and we get 600. And given the volume, which is 9,000 cubic centimeters, then substitute all the given numbers. So volume, which is 9,000, is equal to the base area 600 multiplied to the unknown height. Then divide 9,000 by 600 to get the height, and we will get 15 centimeters. Okay, so there you have it. To wrap up our lesson for today, so to get the volume of pyramid and cone, just multiply the area of the base by the height of the space figure, then divide the product by 3. And the height in the formula for finding the volume of the right pyramid and cone refers to the distance from the apex to the base of the figure. And the last is the volume of a sphere is 4/3 the product of P or pi and the cube of the radius R of the sphere. So once again, thank you and see you again grade 6 for another Math Fantastic lesson. See you again. Bye!